What's up everyone? This video is going to be part 2 of the Tevo Tornado BLTouch upgrade, and this video can also be used if you're just upgrading any printer to 1.1.8. Keep in mind though, if there's either a future version that is released or you're using a previous version, you may find that it's going to be different. So with that said, we're going to go ahead and get started. Alright, a couple things is I'm debating to myself to share the firmware after I did all these upgrades, because I think it's better for users to actually learn how to do it, and to better learn is doing it yourself. So I'm kind of debating that, but we'll see what happens. I will be doing a pretty detailed step-by-step as well, and so yeah, so basically how I'm going to be doing this is we're going to first download the Marlin. I'm also going to then open documentations, so if there's any confusions about anything, we can refer to the documentations. And I'm going to have the stock Tevo Tornado firmware opened as well. So we're going to try to keep settings at the same as the stock Tevo Tornado, because the stock settings work very well for the Tevo. And we're going to also add BLTouch. I'll show you how to do the PID tuning, and in order to do that, you're going to need a terminal linked to your actual printer. I'm using Octoprint. You can use Kira, Simplified 3D, or they have other software that is just terminal to your printer. And we'll use G codes to do those tunes. I'll go over auto leveling and how it works. Basically, I will not go over Z offset though. I feel like there's a lot of videos on Z offsets, and so yeah, so let's go ahead and get started, and if I remember anything else, I'll talk about it. So we're going to go to downloads, or download, and we're going to click on to the latest version 1.1.x, and this is going to be a zip folder. So you're going to have to unzip it, and once you unzip it, you're going to open up the Marlin folder. Should look like this. So this is the Marlin folder. These are tons of libraries that makes your printer run. And so we scroll down to here. Oh yeah, also you're going to need Arduino IDE installed. There's videos out there on how to install the Arduino IDE and basic setups for that. So you're going to need once you find marlin.ino, you're going to open that. Again though, we're going to go to documentations before we do all that. And so yeah, configuration Marlin 1.1 is what we want. And again, it shows you what all the defines mean, and basically will help you if you are confused about something like acceleration and jerk. It does a pretty good definition on those. Boards, it'll tell you what boards are, but we can find that within the firmware as well. So let's go ahead and open up that firmware, and this is what the firmware looks like. And so it has all these files and all that kind of stuff, but we're basically just going to stay into the configuration.h file and the advanced configuration file. And these are the two folders that we are going to make changes to our printer. Some of it's actual equations that will make your printer move the way it does, and so you don't want to mess with anything like that. And so yeah, so let's go ahead and go to the configuration.h file. I have turned on my lines. So in order to turn on these lines, you go to File and you go to Preferences, and you just click on Display Line Numbers. This just makes it easier to follow along. And so first things first, we're going to go ahead and scroll down. We don't need to mess with anything right here. We're not using a Delta printer or any of those. So right here, so line 77. So if you want, this is not required, but you can actually put your name in here because you're the one that made changes to the config file. So I'll just put Eric's do it yourself, and I guess I could just put, because this is the first version of the new Tevo Tornado firmware that I'm putting on there, I'll put 1.1. You're going to make sure all these are uncomment. These backslashes are comments, and if you, and like say right here, you comment this out, the program is not going to read this line. So this is how you uncomment, and now the program will read this part of the firmware. Next, we are going to set up a custom boot screen, and that is line 93. So we're going to uncomment this. So define show custom boot screen. Alright, so we uncomment that. Now I will provide you this file as well in the description below, but basically this is the boot screen right here, and you're going to take this boot screen, so it's underscore boot screen. So this is what it looks like in Notepad. I'm going to go ahead and open it up in Notepad+++, and so you'll keep all these numbers the same. You're not going to mess with anything here. This is right here, so all this makes the tornado when you start up your screen. And so since I want to add that in, we are just going to take this file right here. I'm just going to copy it, and we can go to our Marlin file and we just paste it in here, and it'll paste in here. And so since we have this uncomment, it will now show that boot screen. There's a way to do customize boot screens and all that kind of stuff. I think you can actually put a picture, any picture you want, and make it a boot screen. There's websites out there that will do that. I'm just going to use the Tevo Tornado stock boot screen. Alright, so let's go ahead, and we're going to go ahead and set our motherboard. So right now this is the defined motherboard. This is not the motherboard, however, the Tevo Tornado uses. So we're going to go ahead and delete that. Now we can refer to the documentations right here under boards. We can find our board, copy and paste, or we can actually go to boards here, and here are all the boards. Now we are using the MKS base boards. We are using this board. So there's two ways we can do it. So the developers designed it where we can either copy the number and paste the number, or we can copy the actual board and we can paste the board into motherboard, onto where motherboards is located. So under the motherboard, we could either put the number to the board, or we can actually put the board down. So if we could put 40 here, and that will mean board underscore MKS underscore base, or we can actually just put that in itself, board underscore MKS base. We're gonna go down to, alright, so right here. So when your printer boots up, it shows the tornado. Right now it's going to show the tornado. It'll actually say the author, Eric's Do It Yourself 1.0. It'll say that. And here, after everything's boot up, this is what it will initially say on the actual startup screen. You can put anything you want in here, it doesn't matter. Tevo Tornado ready. Doesn't even need to be all caps, but so say Tevo Tornado and then ready. So yeah, again, this doesn't really matter, doesn't affect nothing. So next we are going to go to line 140 and change our diameter to 1.75. And I know different machines use different diameters, or you can even set up the Tevo Tornado to use a different diameter of filament. But right now it's using 1.75, so I'll put 1.75. See, nothing here. Alright, so yeah, let's talk about thermal settings. Thermal settings, and we are using just the regular 100K thermostat right here. So we do have, so the temperature sensor 0 is the one that is on the hot end, and we only have one hot end, so we're going to put a 1, or it already has a 1 here. And then we also have a heated bed, so we will put a 1 here as well, and they're both 100K thermistors. So let's go ahead. Alright, PID settings. So before you upload your newest firmware, you might want to get your PID tuned. And so basically, again, if we look at the documentation, so PID settings in the documentation says basically it's a stabilizes the dynamic heating system for the hot end and bed, and when set correctly, heaters reach their target temperatures faster, maintain temperatures better, and experience less wear over time. So this is why it's important to tune your PID. And again, each printer is going to be different. So how we are going to tune it, and I already tuned it earlier, so I'll just kind of just go through it a little bit. But we need to go to the terminal, our printer needs to be connected and all that kind of stuff. So we're going to type in M303, and that's just the saying PID auto tune right there. And if we have one extruder, it's extruder 0 we're going to start out with first. But if we have 2 extruders and we want to tune the second extruder, we need to do extruder 2. That's one. It's kind of confusing, but 0 is 1, 1 is 2. And now we have to set our temperature. So S is basically temperature, and I would set it to what temperature you print most at, and my temperature is about 210 that I print at most, and that's for PLA. And actually I'll set it to PETG. That's, I think, what I tuned it at, and that was 245, I think, for PETG. Yeah, so. And then C stands for cycles, how many times you want it to cycle. So basically what it's going to do is you want to start it at room temperature. It's going to turn on your hot end, reach that temperature, shut off, cool down a little bit, turn back on, heat to that temperature, cool down a little bit more, shut off, well, turn back on and heat up. And that's the cycles. How many cycles do you want to do that? Documentation says 8 cycles is good, so we'll do 8 cycles. And so that's just for the extruder. And so if we hit enter, our printer is going to go into auto tune mode and heat up, cool down, heat up, cool down. Again, start both these processes for the bed and the hot end at room temperature. So as far as the bed goes, it's still M303, and for the bed it's E-1. That means we're going to auto tune the bed. Temperature, I would use your temperature you use the most. Mine's 80 degrees Celsius, and I want to do 8 cycles as well. Hit enter. Each of these take, with the Tevo Tornado, it takes about 5 minutes for the hot end and another 5 minutes for the bed. So expect this process to be about 10 minutes. And once this process is done, it's going to actually give you the KP, KI, and KD settings. So, like I said, I've already done this earlier, so I have those settings. So my settings are 20.07, 1.42, and 71.12. This was the PID for the hot end. Now we can go down to the bed. So this is the PID for the bed, and right here. So my changes, and these were actually pretty drastic changes. 210.85, 27.98, and 329.27. The Tevo Tornado actually heats up the bed relatively quick, a lot quicker than my CR-10. That's why these settings are so high, or so different. Alright, so moving on. Let's see if there's anything else in here. Let's see, going down, nothing for mechanical settings. End stops. So end stops, we are going to make changes to the limit switches, and that is right here, X-min. So for our X-min end stop, right now the logic is false, but on the Tevo Tornado this should be true. So what false means is your limit switch is set up where the COM is ground, which is normal, and it usually has 3 wires to a limit switch. One can be normally open and normally closed. Well, false means it's normally closed. However, how it's wired on the Tevo Tornado, it is normally open, so we need to change the X-min to true, the true, and okay, so X, Y, and Z min is all going to be true because these are normally opened. So next we are going to go down to movement settings, and in here we got default axis step per minute, and this is probably the most important setup that you have to do. There's a way to calibrate this. I think you need to know like the number of teeth on your pulley, your motor. There's a whole equation. I think actually on Marlin you could actually see that equation, or you can input all your number of teeth on the pulley, your type of pulley, and you could get these settings. Well, Tevo Tornado already did that, and so I'm going to just use their settings. But let's go ahead and go to the documentation. Yeah, so most crucial settings for your printer, as they determine how accurate the stepper motors will position the axes. Here we're telling the firmware how many individual steps produce a single millimeter or degree. Yeah, not for our printer. These depend on various factors, including belt pinch, numbers of teeth on the pulley, thread pitch, and lead screws, microstepping settings, and extruder style. So by default, Marlin puts 80, 4,500. So let's go ahead, go back to our firmware. The settings that we are going to input for the X and Y. So how it's set up is X, Y, Z, and extruder. For this one, 79.765. That's the stock settings for the Tevo Tornado. 79.65 for the Y. For the Z, we have 399.2901, and for the extruder, 400. So those are coming straight from the stock firmware. Feed rate. So any moves in any move, the velocity in millimeters per second in the X, Y, and Z extruder direction will be limited to the corresponding feed rates. So we're going to go ahead and use what Tevo Tornado put in their stock firmware, because it works and it works good, and which is for the X 250, the Y 250, the Z they put 30, and for the extruder 55. Now acceleration documentation, we can see what acceleration does. So acceleration and jerk play a huge role in quality of your prints. And so looking at the documentation is when the velocity of any axis change, its acceleration or deceleration in millimeters per second squared, is limited by the current max acceleration settings. Also, these jerk settings below, which specify the largest instant speed change that can occur between segments. So a value of 3000 means the axis may accelerate from 0 to 3000 millimeters per minute, 50 millimeters per second, within 1 second movement. So this is key, and I usually mess with these settings a lot, and to try to get the best quality of prints. So it's accelerating at a certain speed. You set the certain speed it accelerates. Jerk pretty much stops it at a certain speed, and you don't want jerk too low or you don't want it too high as well, because you'll either get blobs. I think it says it actually. Let's just go ahead and look at jerk while we're here. If jerk is too low, the extruder will linger too long on small segments and corners, possibly leaving blobs. So jerk's too low, you'll get blobs on your prints. If jerk is set too high, you'll get a lot of ringing, and you actually can skip steps. So I've already kind of done quite a few test prints with this for my printer, and I found that 2000 works, and I think that was actually in the stock firmware as well, was 2000 for the default acceleration. Oh, and before I go too far, right here is the max acceleration. This is just you're setting a number where you can't go above these acceleration numbers. So I can't put this as 4000 because this max is at 3000. So let's go back to 2000. I found that my retraction acceleration is good at 1500 and about 2500 for the actual travel speed. And so this is basically your retraction for your extruder. This is just your normal movements for the X, Y, and Z. Oh, and extruder as well. And then this is just when it's not extruding plastic, just traveling to one spot to the other. It goes a little bit faster because, you know, there's not really endangerment to quality on travel. You don't want this too high though, because you could skip steps as well. Now jerk, I think the stock firmware had 20 or 15. It may have been 15 for jerk. I found 10 works just fine. So 10, 10, yeah, 0.4. This one needs to be 0.4 for the Z jerk, and it's low because your Z axis isn't moving too quick. So that is the acceleration and jerk, and this is actually a setting that you might have to toy with and figure out what is best for your printer. So Z probe, we're going to go to BLTouch next, 640. We're going to delete the 2 backslashes right here, and now it says we have a BLTouch. I'm going to go ahead and scroll down to 686. Alright, so here are our offsets. This is where your printer may be different than mine, but you basically want the probe, you want to measure where the probe is from your extruder or hot end. So from the tip of your hot end to where the probe is. If my probe right now is to the left of my hot end, and it is to the left by 34 millimeters to the left, and it is in front, it is more towards me, so in the front of the hot end by 20 millimeters. So basically mine is 2.2, and I already went through the process to figure that out. I'm not going to show that on this video. It's relatively simple. So there are plenty of videos on how to get your Z offset with a BLTouch. This is already going to be a long video, so I don't want to go into that. Moving on, we will keep our X and Y probe speed at 8,000 millimeters per minute, which is I think 80 millimeters per second. Okay, so this is a new feature on 1.1.8. It used to just say double touch, but now they have it where you can set where it's set to 2 for a fast and slow probe. Alright, on line 726, define Z-min probe repeatability test. You're going to use, this is just so you can enable the command M48 in the terminal. And if we look at the documents, this enables you to test the reliability of your probe. Issue a M48 command to start testing. So in the terminal, we enter M48, and it's automatically going to do a test and give you a standard deviation for the probe. So, alright, so invert the stepper directions, change or reverse the motor connection. So on 752, the Y direction. So we need to invert this as well. And on 753 also needs to be inverted. So right now, basically, if you ran your printer with as this as false, or as this as true and this is false, your Y direction would go the opposite way you want it to, and the Z, instead of, if you want it to go down, it would go up. So we need to invert those. Next, we are going to, so for our extruder, we're going to go ahead and hit true right there. So now we're going to go to define Z homing height, and we're going to uncomment that. It's now uncomment. So, and this is just basically moving from point A to point B on the initial setup. Do you want it 4 millimeters? Do you want the Z height 4 millimeters high, or do you want it higher? And for me, I personally like 10 millimeters. It avoids any type of clips, because with the Tevo Tornado it has that kind of build tack on it, so I put glass on it if I'm doing something that has a large print surface, and because otherwise it's like really hard to get it off that build plate, so I put a piece of glass on there. And so 10 millimeters will avoid any type of clips when it's moving or anything like that. So once we have set our Z homing height, we are going to go to the bed size, and the print space is 300 millimeters. However, the extruder can go 20 millimeters past that, so on the x-axis, so that would be 320 millimeters is the total length that the hot end can travel on the x-axis, and the Y direction is 300 as well. So we don't have to worry about this. No. And Z height is 400 millimeters. Alright, so next is bed leveling. And since we have a BLTouch, the whole point is to have it auto level the bed. And it gives you a whole bunch of different options on how to level the bed, and we get to pick one of those options. I haven't really messed with any other options. I always use bilinear probe because it will probe the entire bed. It's perfect for flat surfaces and all that kind of stuff, and I'll kind of explain it a little more in detail when we get down there. So what we're going to do is go down to 874, uncomment that. That means we're initializing auto bed leveling for bilinear. After that, we are now going to go down to the bilinear bed level area section, which is 910. So if enable the auto bed level linear, or, so these two lines are or, bilinear, then it's going to do all this. On line 913, grid max points x3. So this is the number of times that it's going to probe the bed. And what 3 means is it's going to probe the bed a total of 9 times. So here is what's 3. So this is our bed. It's going to probe the bed 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how it's going to probe the bed. And then it'll come up with an equation and determine, okay, your bed kind of increases right here, decreases up here, and it'll take an average. And so when you're printing that first layer, it's moving ever so slightly to make sure that your print is leveled. Now 4 would be 16 times, so it's probing more times in the same bed surface, and it's doing it 16 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then it's done, and it does the same equation and comes up with your level bed. Now what I do is I do 5 times because it's 25 probes on the bed. It's just gives you a more accurate bed reading. It does take longer. If you know you have a relatively level bed, 4 or 3 could be a good number for you. Me, I'm patient. I can wait for it to level 25 or probe 25 times to level the bed, so I choose 5. So I'm going to change this number to 5. So we're probing the bed 25 times. Alright, so next we are going to set the boundaries for probing. And what my numbers I came up with, so this will put the probe about, I say, 6 millimeters to the edges of the print surface. And then this is just adjusting where you want it to probe on the bed. My numbers I found are I'll keep this at 15. This one for the right probe position is 280, 15, 268. These numbers you might have to do kind of a tuning yourself to see where it probes. So basically you want to see where it's probing, and you want to make sure it's probing your entire print surface, and this is how you would calibrate it. Alright, so with these numbers, the left probe bed position, if I put 15 right here, I found that it gets about 6 millimeters to the edge of the left side of the bed, and then 280 will get me to 6 millimeters to the right side of the bed, and that's where you kind of want it. And as far as the Y position, the front and back, 15 and 268 will get me about 6 millimeters to the edge. And that way you're basically setting the boundaries so your entire bed gets probed. Alright, so once our boundaries are set, let's go ahead and keep going. We're not using unified bed leveling, we're not using mesh bed leveling, so we could skip all this. However, we do need the Z safe homing enabled. So this won't allow you to home the bed outside that probe area. So your probe can't go past the edge, and then basically your hot end drives right into your bed if you don't have this enabled, and because that probe will never hit anything. If that makes sense, I'm trying to think. It won't. Basically, your probe won't go outside the probing area. And this, I think, yeah. So what this that will do is then your home position changes to the center of your print bed. So yeah, it divides it by 2. So yeah, it's going to be home right in the direct center of your bed. The next, the feed rate XY and the feed rate Z, we're changing this to 60 and this one to 8 by 60. Now, this is just homing speeds. It'll control how fast. We're upping the speeds a little to home a little bit quicker than just the stock settings. And I found 60 by 60 for the XY, 8 by 60 for the Z is a decent speed. Additional features is our next section. Now, right here, 1116. So this is our EEPROM. EEPROM, or whatever you want to call it. Basically, this allows you to use the M500, the M501, and M502, and well, in the terminal. So you could save your settings basically through your either through Octoprint or in your terminal. You could save the settings through your terminal, and you don't have to make any changes to the firmware. You could just do it from the actual printer itself to the actual terminal. For me, I'm not going to enable this because I usually enable it, but I never change the settings through anything but the firmware. So if you are that type of person that you like to change settings through the terminal or through the printer, then I would uncomment this. But for me, any changes I will do it on this exact firmware right here. So, alright, so moving on. Alright, so preheat settings. So right here are 2 preheat settings that are actual on the printer, where I could go and it says preheat for PLA, preheat for ABS, the 2 most common settings. So I'm going to change this to, because normally I print PLA around 210. On my CR10 I would print PLA around 190, and that's how I'll set it up, but I found the Tevo Tornado 210 is a good print temperature. So not sure why that is. It probably means there's something a little bit off on my thermistor, but yeah, 210 works for me. And for the bed, since I've been printing with a glass plate on top, I bumped up the temperature to 80 degrees Celsius. Now this is supposed to be ABS, however I'm set this to my PETG settings, and my PETG settings is 245 degrees hot end and 80 degrees bed. I don't really print with ABS, never have, but I am a fan of PETG. Alright, so this is a feature that we have to enable in order to get an advanced feature called advanced pause, and that's in the configuration_advanced file. So it's in this file, and we'll get there soon enough, but we do have to uncomment so that feature will work. And the clean nozzle, this is experimental. I guess it's up to you if you want to enable it. You don't have to. Let's go ahead and move on. LCD and SD support. So here we're gonna make some changes. We're gonna enable like the SD card and all that kind of stuff. So right here at 1332, we are going to enable our SD card. At 1359, use this option to override the numbers. Okay, so this is to enable our encoder. That's our little like wheel on the LCD. The LCD screen helps you select features from your printer. And we are going to change the 5 to a 1. We're going to change it to a single step. Next I'm going to, you guys don't have to, this just reverses the encoder on the LCD screen. Basically, if I turn it clockwise, it's going to move your menu down. So it's going to move your selection from the menu downwards. If you turn it counterclockwise, it's going to move it up. And that's the way I like it. You might like it the other way, so you can keep that commented out. Next, we are going to go to 1395, uncomment this, define individual access homing menus. So this just makes it so you can home X and home Y and home Z individually. Next is the speaker. Again, you don't have to if you don't want to hear the speaker going off. Primarily, you want this uncommented if you have EPROMs or EPROM, because this will tell you if your settings were saved. It will beep at you if you saved your settings. Next, we're going to go down to 1484 right here. So we are using the RepRap discount full graphics card graphics smart controller as our LCD setup. So we want to enable that, and I think that is it for the configuration file. Let me check. Yeah, so that is the end of configuration.h file, and now we can move to the advanced file. So this is just more advanced features and settings that you can set up for the Tevo Tornado. We're going to go ahead and move down to line 200 and what is it, 217. So we want to set this up right here, the extruder cooling fans. So this just makes the fan automatically turn on when there's extruder temperature goes above the extruder auto fan temperature. Basically, if your hot end is hot, your fan is on. When it cools down to a certain point, your fan turns off. In the stock settings, this is set to pin number 7, and so that's where the fan is located, is pin 7. -1 just disables these features right here. We only have one extruder. So now we're going to go down to mechanical settings, which we're going to look at 363, lines 363. This feature right here is not required. I like to have it on. It just kind of helps it be more accurate in a way. So I'm going to go ahead and uncomment this. Basically what it does is once your stepper motors are deactivated, it will rehome itself. That way if I bump it and the stepper motors are disabled, then it's going to rehome anyways. So it just makes it more accurate. It does take a little more time. Alright, so we are going to go to 579. So these two allow, basically, so this first feature allows the host to request long names for file and folders, and this allows the option to scroll through those long file names and folders on the SD card. So we want those two uncommented. Alright, so next we're going to enable baby steps. And basically baby steps, it's just allowing you to move the axes by tiny increments, like how it says it right here. And so first off, we're going to enable baby stepping. Then we need, since we have a Z probe, we're going to enable the baby step Z probe offset. Then we're going to enable the baby step Z probe GFX overlay. So the graphical overlay on the Z offset. So we can now go to 679. Alright, so now this is the part I spent a week trying to calibrate this. This is kind of a new feature. I'm not sure if 1.17 had it, but it's here in 1.1.8. But it wasn't in 1.16. So this is a relatively new feature. And so this is something that is not required. And I've been messing with these settings for almost a week now. And I'm not sure if I really like this feature, honestly. I know the stock settings had it disabled. I was trying to enable it because, so here's the documentation on it. This feature allows Marlin to use linear pressure control for print extrusion to eliminate ooze, improve corners, etc. See configuration or basically the advanced configuration file and linear advanced page. So here is more detail on how it works. Basically, I notice when this is enabled, it makes the printer louder. It sounds like your extruder stepper motor is skipping steps because it's trying to control the pressure, the filament, in the hot end. So it's trying to control that pressure. And it tries to do like micro steps and all that kind of stuff. And so it's louder, sounds like it's skipping steps, and it seems like it vibrates more when it's enabled. And I know it's a new feature, but for me, the quality isn't actually better when it's on. I think the quality's worse. But then again, I spent a whole week changing the constant number and trying to find that right value where it decreases vibration and try to decrease the noise a little. The end result is basically I'm just going to have it off. My quality goes higher when it's off. The printer's quieter. It's not trying to control the pressure on any type of curvature. And so, yeah, I'm just going to turn off the feature, and maybe whenever I have time, I'll start messing with it again and try to figure out if it's even worth the trouble to try to get it to print smooth with it. And actually, if any one of you guys have a great linear advanced settings, let me know, because I'm having trouble with it. So next we are going to go to the advanced pause feature. I am going to uncomment this, and advanced pause is an experimental feature for filament change support and for parking the nozzle when pause. This is so if I did not have the park nozzle uncommented from the configuration.h file, then whenever we verified the firmware, this would have came up with an error saying that the advanced park or the nozzle park feature needs to be enabled for this feature to work. And so I don't mess with any of these settings. This is so you can do change filament basically, and it'll park the nozzle for you and everything like that. So, and it will enable it on the LCD screen as well, I think. Yeah, so it requires the LCD's display and all that kind of stuff. So it's also, if you have a filament run out sensor, it's required if you have that on to have this feature on as well. Alright, so scrolling through here, making sure I didn't miss anything in the advanced features, and it looks like I got everything. So we're going to go ahead and now go to tools. We're going to make sure our board is the Arduino / genuine Mega or Mega 2560 is on. Once that's enabled, then we're going to make sure our processor is going to be the Atmega 256 or 2560. And whatever port we're in, my port's not on, I don't have it plugged in right now. And we're going to make sure our programmer is AVRISP, and then the MKLL. So that's what we need to actually put the firmware onto the board. Alright, so before we verify and make sure the program is good, that I didn't make any mistakes, we have to add the underscore boot screen to here, so we can actually go to the folder where we added the underscore boot screen.h, and we could just move it up into here. And so basically that just adds it into the libraries. And so now when the function call, or when it calls for underscore boot screen, it's in the Marlin INO. So let's go ahead and verify and make sure everything is happy, and this may take a minute to do so. Alright, so we are done compiling, and now we could see how much we're using of the board and memory on that board, but we are within our limits, so we're good on that. And so now once we have our right COM port selected, we can actually upload to the printer once it's connected. So you got to connect the printer and hit up and select the correct COM port, make sure you have the right board, hit upload, and it's going to recompile it, and then it's going to upload to your printer. And let's go ahead and now do a test print. Alright, so we're going to go ahead and start a print. This is my script right in the bottom right hand corner. G28 for a home all axes and G29 for level the bed. Notice how it's doing the double tap, and that's what we inputted in the, and it's going to be probing 25 times on this bed. Once the auto level is complete, it's going to prime the nozzle and do a quick wipe. Alright, our print is complete. We can go ahead and check it out, and let's just check quality, and it looks really good. There are a few areas that need improvement, but this isn't an improvement with the firmware. It'd be something with whatever slicer you're using. I'm using Simplify 3D. I might mess with the retraction settings, but other than that, it turned out really well. Here is the first layer, and it turned out really nice. All in all, this firmware upgrade was a great success. I know this was a long video, but I hope this helped some of you out. I have decided to leave the firmware down in the description below, along with all the Marlin documentations and everything like that you can find down there. If you have any questions, leave a comment down below. I have been really busy, so it's been hard for me to get to everyone's questions, but I will try to get to you. If you have anything to add, or if I misspoke about anything, also leave a comment down below. I do make mistakes, but that concludes this video. As always, thank you all for your support, and thank you for watching.